So in the past couple of weeks, I started taking a deeper dive into C++, just because I wanted to feel something. This is coming from a JavaScript slash TypeScript developer, and it's fun, you know. I do like JavaScript, but it can sometimes feel like alcohol, you know. You get a bit tipsy, it's all fun and games, but then you have to deal with the hangover and the headaches and your wife shouting at you, and I wanted to give a shock to my system, go straight to LSD here. And it's been really fun. I've been really enjoying it. I got quite interested in embedded systems and how like game engines work. It's something I'm interested in doing in the future. But whilst doing this, I realized, oh my God, how different JavaScript is from all these like your typical standard programming languages like C and C++. So I thought to myself, hey, wouldn't it be great to actually make a video covering kind of how JavaScript works? Because I feel like if you really understand how it works, then it's much easier to kind of comprehend these other languages. So that's what we're going to do today. We're going to talk about JavaScript, about how closures, global execution context, scopes, and all of this works, the parser and whatnot. So come along and let's have some fun, will ya? And subscribe, will ya? But if you also want to learn C++, this is what I've been using, and a lot of people have been recommending it. It's called learncpp.com, and it's been great. I guess the only thing is that it's 90% ads, and there's like 10% code on it. But other than that, it's fantastic. I've been doing it for 2 weeks, and I already own a Stanley and a 2-week subscription to Travelodge. But yeah, okay, so I have a little Excalibur here. We're going to do a little bit of drawing, and I am going to apologize now for it because it's going to be horrendous. And I also have a little Neo of him here. So I just created a simple file here, an index HTML, right? We just have a script attached to it, and also an app.js that's just currently empty. How's my mouth dry already? Stay hydrated, folks. I usually recommend alcohol here, but you can do water as well. Okay. So the thing with JavaScript is such a weird language. You know, if you've done stuff with dates, you know how convoluted it can get. And the Mayans were involved with that, but I'm not going to get into that. That's for another video. But even if I don't write any code here, well, let's write a bit of code. I'm going to let x equals 2 plus 3, right? Okay, so I'm gonna run this sucker. So I have tmux here, so I'm like running a live server. If we look at inspect here, I can do x, right? If I type x and hit enter, we get 5. So we know this does get saved somewhere in memory, which is great. You might know that. But a lot of other different things happen in the background. So if I do window here, we get this big giant object that has a bunch of methods on it. So where did this come from? And then you also have the keyword this that gets initiated and it means something. This is the biggest snitch, by the way. It keeps pointing its fingers to other stuff all the time. He's an asshole, but we're going to cover this as well. It's a whole shenanigans with this keyword. But a lot of stuff happens, right? So what does really happen here? Well, if we really break it down, there's 3 really like important steps, I guess, that happens. The first step is the JavaScript engine has a parser. And then there's also a execution context. And this is, I'm going to say here, the creation phase. And then finally, your code actually runs. Or you're going to hear it called like the execution phase. So let's talk a little bit about each, just so we kind of understand what's going on here. So what's the parser? So that's just a component of the JavaScript engine that essentially tries to identify the code that you've written. It tries to break it down into the keywords, right? If it's part of the JavaScript language. So you can imagine that the text is just basically text that gets passed to the parser, and it tries to understand if it actually means anything. So let is a keyword in JavaScript. It means something. It means creating a variable, right? X is actually the identifier here. Equals also means something. It's an operator in JavaScript. It's just like plus. Plus is an operator as well. The values here are literals, right? So it's going to look line by line. It's going to ignore the spaces. It doesn't really care about spaces, or if you have empty spaces like this. That's like the parser completely ignores all of this, and it's just going to get removed in the end, okay? So it's going to look at this, and it's going to kind of break it down into small little boxes, you can imagine. So if I go down here, I'll zoom in a little bit. So for that example, it's going to basically break these down like this. So let, well, that's a keyword, it's going to say. And then you have X, right? That's the an identifier. And then it keeps going like this through your whole code. Equals, what's that? That's an operator. All right. And then it goes to the 2, right? And then that's a literal, etc., etc. And it goes through all of this, and it's going to create something called an AST, an abstract syntax tree, that just kind of creates a graph and like connects everything together, kind of the order of everything. So at the top level, you can imagine you have like the program that we're running. And then what do we have here? We have a variable declaration. So it's going to keep track of it. It's going to say variable declaration like that. And it's also going to know like what kind of keyword we used. So we use let. And then a level deeper now here, see, it's going to create kind of this like tree type structure. We have the identifier, ID, and that's going to be X, we named it, right? And then a level deeper here, we also have our binary expression. And here, I'm just going to say plus, right? Because we have the plus operator. And then we add the two numbers together. So we level deeper here, we have the literals. Literal, literal. So we have the 2, and then we have the 3. So if you wonder, like, well, how does JavaScript know, for example, if I have like 2 plus 3 times 5, right? It needs to do this operation first. If you know anything about math, you do 3 times 5, 15, and then you add the 2. Well, when the parser actually creates this abstract syntax tree, it's creating this kind of tree-like structure. It's going to know how to add these together, right? So you'd have maybe the 2 times 5 here that does the multiplication, and after that, a level deeper now, it's going to do the plus operation. So it kind of keeps them separate. It knows like what to add together first and then what not to. So that's really kind of the main point of the parser. It's actually a component of the parser called the tokenizer that essentially breaks them down into these little chunks, and then it creates this tree-like structure for you. All right, so you have this tree-like structure, and that's all you need to do. So if you wonder where your like syntax errors gets caught, it would be when the parser runs through this with the compiler. So if I have something like let 3x here, it's going to throw an error for you. So if I go back here and look at the page and I reload this, see, it says it's an invalid or unexpected token. So this gets caught before your code even runs. And that's really it. Eventually, this abstract syntax tree gets passed to the engine, and then some things happen there, but that's not too important for now. Okay, so we kind of have an understanding what the parser does. What's the next step? The next step is this execution context, the creation phase. So what happens here is, besides this, when we declare a variable here, this gets saved in memory. Okay, so that's the first thing that happens. But the other thing that happens in the background is that the global execution context gets initialized, and we're going to talk about what this is. Another thing that happens is that the keyword this gets set. And another thing is that the window object also gets instantiated. And this it depends where you are. If you're in the browser, on client side, you'll have the window object. If you're in something like Node.js, you won't have stuff like, client with and stuff like that. You're not really working with a browser environment, so you're not going to have those specific methods. So it's going to look a bit different. They have a global object here that's called. But that's essentially it. When the global execution context gets created, the this keywords get set, the window object gets created, and actually another thing that happens is the lexical environment gets created. Okay, and what the lexical environment is, it just keeps track of basically where your code is and what that specific scope has access to. And it also keeps track of the outer environment. So in JavaScript, you can imagine if I have a function here, for example, let's call it greet, right? And I try to access X. The way JavaScript works, if it doesn't find X within this function, it's going to look on the outer scope to see if it exists there. So that's what the lexical environment is. You can imagine that that abstract tree, right, that we created here gets passed down to the engine, and it creates that lexical environment where it knows where everything is, like physically in the code. So it knows that X is on the outside here of this greet function. Because if you have another X here, that would work. If I do let X2 here, then X would be 2 here. But if I don't have it, it would look on the outer scope and it would set it to 5. Okay, so that's it. So when I just write code like that, the global execution context gets created, which is just the environment where your code runs, basically. The keyword this, the window object gets created, and that lexical environment also gets created. Okay, cool. So we know that. Now, if I create another function here, let's just get that greet back. When you create a function and you invoke a function, another execution context gets created specifically for it. So let's do a console log, and I'll just say hello here. So for example, if I go down here and if I say console log X, and what I'm actually going to do is move this function down here below. So how do you think this is going to run? You're also going to hear the term that JavaScript is single-threaded. Basically means that code is ran line by line. So it's going to run this line, this line, this line, this line, this line, this line, etc., etc., etc. Okay, so in this step, what essentially happens is as soon as we run this code, the global execution context gets created. And this gets created on something called a call stack, which is just like a simple data structure that has a first in, first out, a FIFO. You're gonna hear that term, call stack. So it's like basically like plates. One gets added, a new one gets added, and they run in this order. And then when this one finishes, the top one, it gets removed. And then this one continues running, gets removed, and then this finishes, so everything is removed. So you can imagine it's like a big box where all these execution contexts get laid on top of each other. Okay, they get quite spicy. So if you don't have a function, invocation is just the global execution context gets added. So like this, I'll call it G. Okay, so if I don't have this, basically, I remove it. I just have the console log. This gets saved in memory on the first line. Console log X runs, and as soon as it finishes, this gets popped off, and everything is done. The program closes. That's it. Now, on the other example here, where we had the function as well, it's a bit different. This gets instantiated and saved in memory. But as soon as we run into the function invocation here, this gets added to the call stack. So the global execution gets created. As soon as we run into this invocation, a new one gets added here at the top. So every time you invoke a function, a new context specifically for that function gets created with its own lexical environment. So this would be greet, right? Now this execution context here, the global one, stops, completely stops until this whole greet function finishes. So from here, we don't go directly down to console log x. Instead, we jump into the function here and we console log hello first. And once everything is done here, in this case, it was just one console log, it finishes. Then this gets popped off the top here. And now we can continue running the global one. So we can finally go here and console log out x. And we can see that. So we open up the browser here and do a refresh. We should also we get hello first, and then we get x. Now, how come we can run greet here at the top and we can invoke it and it works, right? How come that this doesn't need to be at the top here like that? Because you may notice that if I have changed this to a variable instead, and I go here at the top and I try to console log it out, and then I try to console log it out after here as well. Let's hit save. As you can see, I get undefined first, and then I get 5, and then I get hello here. So what's going on? Well, this is what hoisting is. When the creation phase happens with your global execution context, all your functions get hoisted. It means that it's going to look and find all your function declarations, and it's going to save them in memory beforehand. It used to do it the same with variables, where it would find them and it would just explicitly set it with a undefined value, which might cause a little bit of weirdness when you try to access it beforehand. But thankfully, with modern JavaScript now, you'd use either let or const. Let stands for that you can like change it. So if I do x equals 5, that would work, or 10. Const is a constant, so you wouldn't be able to set the value and change the value like that. But with let x, for example, if I do it, as you can see, you get a reference error. So you cannot access x before initialization. So it stops you from doing that. But that's a little thing that you should know, is that function declarations do get saved, and you can invoke it beforehand if you want to, and it works perfectly fine. They don't get like physically moved to the top or anything. It just kind of does a run beforehand and saves it. So when the code actually gets executed, there's already a reference available, which is going to be, if you do like a window object here, you're going to see that it lives there. So if we go here, we called it greet. When does G come? A, B, C, D, F, G. I passed that, haven't I? We should have greet, and there it is. See, it's on the window object. Okay, let's look at another example here. So we have a x, we have name here, and then we have greet function that also calls a different function here called capitalize name, and it just capitalizes it, and then we console log it out. And then let's say we have something else that runs here. We console log out x. Okay, so how does this run then? Just so we have a much clearer understanding now. Okay, so first thing, again, the global execution context gets created. So this, and the lexical environment for it as well. So where everything is in place, and also the window object, the this keyword, and also the outer environment. Now, in case of the global execution context, the outer environment is set to null because there is none. Like, where are we going from here? Outside of NeoVim, basically, right? So that gets created. Then all the hoisting stuff happens. So these get saved in memory, the greet and the capitalized name. These get created as well, but they are left undeclared, uninitialized. We run through the first line of code. We finally set x equal to 5. We run through the second line here. We set name equals to Edwin. And then we basically, let me just go here because we never invoked this. Let me add greet here. We don't go here to console log X. Instead, we invoke greet. So we jump into the greet function. So we jump into the greet function. This gets added to the top. So now we're executing the greet function. We initialize cap and set it to equal to the other function. So we're invoking another function here. So that gets added to the top. Capitalize. Right? So we don't run console log here. We wait for this to finish. So we jump from here all the way to capitalize name. So here we do the to uppercase. There's nothing else in here. So this finishes running. So this gets popped off. And now we can continue in our greet function. We go over to console log. We console log out the capitalized name. This finishes running. So then this gets popped off. And finally, we can move on with what's left, which is the console log X. And that's it. And that gets ran. And then this gets popped off as well. You might have also heard about the scope chain and scope. It basically means the region of code where certain variables are accessible. So here, when we run the greet function, right, we pass a name, which is going to look on the outer lexical environment. So greet is going to look, okay, well, I'm accessing a name. I don't have it here, so I'm going to look on the outer scope, which is our global scope. So it's going to find Edwin here. So it's going to use that. However, since each function gets its own lexical environment, if I have name here initialized as something else, like hey, it's going to use this instead because this is the closest one it has access to. See, it gets hey. So there's the global scope. There's function scope as well. So if I have maybe another one here called count, and I'll set that to 0, this is not accessible outside of it, right? So I kind of go here and say count, right? That's not going to work. That's going to give me an error. It's going to say it's not available. However, within here, if I have another function, for example, within this function, say count, then that's perfectly fine. See, you can kind of see the structure of it now. This gets its own lexical environment, so it's going to look on the outer scope, and it's going to find count, right? So there's global scope, there's function scope, and there's block scope as well, which is if you do something like an if statement, if something is true, if we have name available, then I can declare a variable here, test, like that. So that's, again, only available within this block scope. And that's pretty much it. So the scope chain really is when you try to look, that's it. When you try to look for a variable where you call something, it's going to look up the scope. It's going to look through this lexical environment until it finds the first match. That's basically it. It keeps going up until it reaches the global scope. And if it doesn't find it in the global scope, then we're done. So let's talk a little bit about closures as well. So let's say we have a function, and I'll call it create counter. And I set let count equal to 0. Okay, and then I console log out count. Okay, cool, right? There we go. So we have that. Now, another important thing that happens, so we run create counter, and we get 0. So again, that gets added here on the top, right? But what also happens is that the variable here also lives in this like execution context. So it keeps track of it in here. Let count equals 0, right? And when this finishes running, right, it gets popped off, this variable needs to be cleared, right? It needs to be garbage collected because we don't want to have it saved in memory anymore. There's no point to it. The function has completed. It finished running. It served its purpose in existence. Poor little fella. So it gets deleted, right? It gets passed to the garbage collector, and it's all handled automatically for you. In languages like C++, you'd have to kind of manually do that to clear all that out, but this is all handled for you. Okay, so that's one thing to keep in mind. But then you realize that in JavaScript you can do something like this. So rather than console logging out, I'll still have the let count here. I'll return a function instead that does count plus plus. So I increment it by 1, and then I console log out count like that. Okay, cool. So now if I do counts counter, I'll create the counter, which basically returns me the other function here, right? So I should be able to do counter a couple of times. So I'll just save that. There we go. So what do you think happens? Well, if we have a look, we actually have 1, 2, 3. How? That makes zero sense, right? I literally just told you that once this function finishes running, everything gets garbage collected. So how come the count still like exists and stays alive? Well, there's this concept called closure in JavaScript. And basically when we run into a situation like this, where we are returning a function, or we have another function within here that needs access to the outer scope here, like count, it's gonna essentially move that over from the call stack. So you can imagine how we had it here, right? We had the create counter that had the let count equals 0, and then we return the other function, right? So this should all be like cleared out and removed, but instead JavaScript, through like the lexical environment, knows that the count function here needs the variable and relies on that variable. So it detects that, and it takes this, and it dynamically basically takes this variable and moves it out of the call stack into a whole different like data structure called a heap here. This is where your like objects and arrays get saved because they're quite unstructured data. So it actually gets moved there and keeps a reference of count. So count equals 0. So this lives here now, so it knows to reference that instead. So that's why when you, even though this like finishes running, we still have that count saved in another part in memory. And then we can just say counter here, and it's going to keep referencing that value and just incrementing it over and over and over again. That's pretty much it. That's kind of the whole idea. And this is used everywhere. That's why you can do something like, let's say you have again, a count value like this, and then you might have, in JavaScript, let's say we have a button, and then we do an add event listener, and then we have the event, right? Sorry, how do you do this? Add event listener, it's a click one, right? And then you have the event, there we go. And then you run this, and then you do console log count. This is kind of like a closure as well. Since like the program technically finishes running, right? This count should get garbage collected. But since this relies on the value up here, it's going to move it over to the heap, and it's going to reference that over and over again. Let's talk about the keyword this as well a little bit. It's a special keyword that refers to the object that is calling the function, basically. So in like the global context here, if I just say this, it's always going to reference the window object. So here, or in terms of node, it would be the global object. However, if I do an example like we have an object here, like const person, set that equal to, have a name, add, comma, and then I'll just say hi function, for example. There we go. And I just do console log hey plus, and I do this dot name here, like that. If I do person dot say hi, let's see what we get. We get hey ed. Okay, so it's going to reference this object. The easiest way to identify this is to see where you're invoking the function. and just look to the left of it. So on the left of my invocation, I have person, right? It's a method on the person. And that way you're going to know what this keyword usually means. If you're going to find a function that's just kind of invoked on its own like that, it's most likely it's going to refer to the global object. So that's a little trick that you can use. So like I showed you, if I do person dot say hi, we look to the left, we see it's person. So there we go, we get the person object. However, even if I just save this to a variable, right? So I say greet equals person dot say hi. So I'm just passing a reference down. If I do a greet and I invoke it, you're gonna see that we get the window object. Okay, so we lose the context here. Again, just look to your left. I'm not passing, it's not a method that gets attached to here. So it gets called on its own, so we lose the context. Now, one different thing with arrow functions that you might notice is that they don't really care who calls them. It just sets the this keyword from the surrounding scope. So in this case, with the arrow function, the this keyword will actually be the global scope here. So we're gonna get nothing. So here in the normal one, it always references the person. However, here it won't. So as you can see, we get nothing. I also want to quickly show you how you can manually set the this keyword, because you might have something like this. We have a function called greet, and let's just say console log this dot name, for example. So now you should know if I try to do greet, that's just going to be undefined. But I might have a user down here, right, with a name of Ed, and I basically can manually set the this keyword. So that's where you can use something like call. So I can say the greet dot call. As you can see, I have method on this, and I can pass in the object that I want to use. So user, and there we go. That's it. And I get Ed here. So we're manually setting the keyword this. We have apply as well, which is pretty much the same thing. We just have the availability of also passing down parameters. So as you can see, I'm doing the same. I'm passing user down, but for the second parameter here, I can pass hello and an exclamation mark, for example. And there we go. And if we check that, as you can see, everything works the same way. You might have also seen the keyword bind. This is a bit more interesting. It doesn't call the function right away. As you can see, we can call bind here. So nothing actually gets ran here. We're essentially creating a new function here and setting the keyword this. So after that, we can run say hi to Edwin anytime we want. And as you can see, we don't have, this is why I said, usually, like if you don't have anything to your left, like person here, it generally means we're referencing the global window object. But if you use bind, then no, this creates its own function here that actually sets it. So if I call say hi here, even though it's on its own, it is going to reference this user object. And if we have a look, there we go, it says say hi to Edwin. Okay, so those are a couple of things I'm going to get maybe a bit deeper into. There's still a lot of things, because then I want to cover like how does async really come into hand here, and a bunch of other stuff. But if you enjoyed this episode, let me know and I'll happily make a couple more. Okay, until next time, take care, have a lovely day.